All right. So we are going to get started today on a short webinar on finding the right data sets and metrics for evaluating LLM performance for production. Super excited to talk about this, and we're going to blow through kind of lots of topics and things to consider when deciding which data sets you have and which type of evaluation you can do with the data that you have available for LLMs. Okay, so this is our agenda. So first we're going to go through an introduction just to myself and to YLabs. Then we're going to talk about some fundamentals for AI evaluation. So this is going to be a lot of concepts. Many of them you're probably familiar with, but these concepts really do, I think really thinking about the nuance between the concepts is what enables you to make sure you're using the right evaluation and collecting the right data. So we'll go through those briefly. And then we'll talk about challenges specific to generative AI, text, and LLMs, because all of these things present different challenges when thinking about evaluation. And then finally, we'll be comparing some evaluation techniques for accuracy, realism, and convenience, using some of the terms that we've established earlier, and hopefully just giving kind of a multitude of different approaches that people use. All right, so let's get started with an introduction here. First to myself, so I am Bernice Herman. I am a senior data scientist at YLabs, and I work on all sorts of things, approximate statistics, real-time monitoring, kind of have a very data-centric approach to AI, and work specifically on the applied ML and AI models here at YLabs. In the other half of my life, I work as a research scientist at the University of Washington. And I don't always mention this, but this is important because my topic that I do academic research on is evaluation metrics for machine learning. So I hope that you guys realize I'm really excited about this topic, and it's really important kind of in ways that cross both academia and industry. This is a live session, so hi Raghav, and I will be trying to monitor the chat for questions. This is a pretty short presentation, so I have some different sections. I'll most likely try to do all of the questions at the end of a section, and we have about 4 of them. Okay, so a little more about me. My role within YLabs is maybe unsurprisingly, really focused on the statistics and machine learning side of things. And that touches so many pieces of YLabs. But the pieces that you'll see a little bit of are LangKit and YLogs, which are open source projects that we maintain at YLabs. And then the platform itself, so the YLabs AI Control Center. Okay, so there are many different pieces, and I won't talk about all of them because we're focusing today very specifically on evaluation metrics. But I just want to point out that YLabs, to introduce you to that, provides AI control. And this really looks like a couple of things. So one is observability. So being able to observe and monitor your AI model and really the application that surrounds your model. So things like model performance, measuring model drift, data quality, LLM response quality over time, and giving you tools to evaluate and test, receive alerts for your team, and root cause any issues there. Also, we have tools very specifically to LLMs that allow you to prevent issues in real time. So in addition to kind of observing and monitoring, which can be really fast and help you to find issues very quickly, it's not quite as quick as stopping or controlling issues as they're happening. So for a single kind of instance, or maybe I should say for a single inference instance, we may want to decide that, hey, the question is a security concern or things like this, and we want to prevent sort of adversarial or malicious use, poor experiences for the customer. Maybe you want to change directions and responses, or untruthful responses. So all of these things are common in LLMs, and providing tools, guardrails to do this, tracing and debugging tools to do this. Okay, so the larger structure. So YLabs is really set up to focus on kind of a privacy preserving way of doing these things and doing this at production scale. So this is a very high level of how this works here. You have data coming in from the left from many, many different sources. This might be prediction data, training data, streaming data, batch data. And we take all of that data and we capture statistics from that data. So YLabs provides a SaaS platform, but you're not necessarily passing in your real data. We don't want that. We want to be very privacy preserving. And often what we need is just signal from this data. So what we capture are things like distributional statistics, missing data statistics, different summaries that can be helpful to capture the statistics that we need to understand what issues are happening in our system. Then this gets passed into our observability platform where we can aggregate those statistics over time and forecast and detect and visualize and send alerts for issues that are going on. And you can do things like create dashboards and trigger different workflows and notify your team members. I see a raised hand. Go ahead and type in your questions into the chat and I will try to get to them at the end of the section, or if relevant, try to look at those in real time. Okay, so just a brief mention of YLogs here. So YLogs is one of our open source packages that's really about creating the right telemetry. And so creating the right telemetry for LLMs and for machine learning in general often means that we want to find these statistics that I just mentioned and very particular statistics for different types of issues that we're trying to detect. And we use this using data sketches and a data profiling approach. Feel free to watch another video maybe to go further into that. And then there's LangKit, which is another open source tool of ours. This is really focused on text and LLM specific metrics. So we'll talk a lot more about that today. And then finally, this can be passed into the YLabs AI observability platform, where all of this information can come together and we can monitor and find actionable insights on the statistics we've captured. Okay, so now let's get into the meat of our presentation here. So again, we're going to start with the fundamentals and some concepts, and then quickly move into some text-specific things, and then finally some ways of thinking about the data sets that you need and finding the right data sets. Okay, so this starts really high level, but so intelligence, right? So we're talking about artificial intelligence, and we'll soon move to machine learning, but intelligence being the ability to solve problems kind of despite uncertainty. And artificial intelligence being kind of the science and engineering of using machines to resemble that intelligence. So you might say something like a number of books that can translate a language are not intelligent, especially because this is about kind of in an uncertain environment and being able to pull multiple pieces together to solve new problems in an uncertain environment. Same for a maybe robotic machine that while it may do something very precise, if that machine is kind of pre-programmed to do the same thing over and over again, we wouldn't say that that's intelligent, even if it is something complex that it's doing. Machine learning, many of us will know the definition here, but there's many definitions. I would say high level, it's using data and algorithms to enable AI to imitate the way humans learn. So this is an emphasis on learning. There's a great definition by Mitchell here in his book, Machine Learning. It's a little dry perhaps, but a computer program is said to learn from experience, E, with respect to some class of tasks, T, and performance measure, P, if it is performance tasks in T, as measured by P, improves with experience, E. So what we're saying is we're measuring some performance, and we have to measure that, and we want to see that that improves with some experience. So in machine learning, as we think of it today, that E, that experience, is often data. So as we have new data and pass this into our algorithm, we want to measure some performance. And right, this performance is kind of the emphasis that we're going to focus on today in today's workshop. There's kind of loss functions that are used for the learning itself, and maybe different performance measures for measuring the system overall. We're going to focus on the latter, the measuring the system overall. Okay, supervised learning. So this is a paradigm where desired output, like labels, are used to train a machine learning model, and we also use inputs. And that differs from unsupervised learning, which is a paradigm where no labeled data is used to train the machine learning model. Often we use properties or heuristics. And so supervised learning is much more common. So I'm sure you guys have all encountered this. Unsupervised as well, but just as a reminder here, we have like clustering. It's a very popular task. This is an unsupervised task because often we don't have labels. So this blue and green color here is produced by our machine learning algorithm. It is defining some cluster for some data that's received, but there's no real ground truth or desired output that was passed in. There's no true answer to what made a cluster, or at least we didn't have data for that true answer for what made a cluster. And thus, we're just taking the data and using density or some other heuristics to determine our output. Okay, so now that's the learning side of things. How do we move over to evaluation? Well, evaluation is about measuring performance of the model relative to some desired result. So our ground truth or some expectation. And we often think about these things in the terms of ground truth, but I want to expand that today and really focus on both sides of the aisle. So one way to kind of think about evaluation, especially as we compare it to other techniques that we use, especially in production machine learning, is that evaluation is really about determining if there are any issues in our system and which issues those are. And so here's some just examples of how you might go through an evaluation process for a model that you're training. And now that we've thought about evaluation, I want to come back to this idea of supervised and unsupervised, or labeled and unlabeled evaluation metrics. So you can mix these two together. You can have unlabeled or unsupervised learning tasks, but use labeled data to evaluate. But we can also evaluate without labels. And this is something that is very rarely talked about when you're first thinking about machine learning, because we often have labels available to us because we're using very simple data, or at least data that's been collected in academia. We'll see some more of that later. So evaluation with labels, some examples that I'm sure you're familiar with are things like accuracy, F1 score, this sort of thing. Evaluation without labels, this relies on some sort of heuristics or general principles that we can use and combine to come up with a measure to evaluate our system. And a common one that you've seen if you've looked into clustering is silhouette score, and similar scores like it. So for example, if we're trying to do some clustering, we don't have any ground truth labels, or we may. So I guess I should say, in some cases we do. We've maybe produced these data points here on the right with some process in mind. So we know for sure what the label should be, but then there's some noise added or something like this to spread them out some way. In some cases, we don't have labels. Like there is no actual answer that we're comparing to, but we do have some sort of heuristics. So for example, we might say something like, I think my clustering algorithm did a good job if there's a wider distance between two different clusters than there is a distance between 2 points in the same cluster, right? So this intra versus inter cluster distance is a common thing to think about when evaluating clustering, and that is an unlabeled process, right? We don't have any actual answer of this data points in cluster A and this data points in cluster B, but we have some heuristics about what we'd like to see for a cluster. Okay, so now the last couple of concepts here before we move on to text-specific things. So monitoring. So we talked about evaluation, and evaluation, for the most part, requires some data, some very specific ways of measuring the performance of our model. And it's often for one instance. So intrinsic to this evaluation is some sort of comparison, whether or not that's that labeled data, which is the common one. But maybe there's some other benchmark, like the comparison between inter cluster distance and intra-cluster distance. While monitoring is a way that we can think about something very similar to evaluation, but we don't need the benchmark necessarily baked into the measure. We can instead use relative performance or relative metrics, and we often think about monitoring over time. So maybe instead of trying to find the accuracy percentage for my model, which would require me to have some labeled data and tell me which of these example my models got incorrect or got correct, we can instead compare some statistics about the data that my model produced yesterday to today. And this relative performance can be very indicative of issues in our model, right? So if there's vast changes about how our model answered the queries that it received yesterday compared to today, this tells me a lot of information and is much more helpful in production where you're unlikely to have those labels or heuristics that apply well. And then finally, we have observability. So this is kind of going even beyond monitoring. So both evaluation and monitoring are really focused on kind of the overall system. And observability is about informing what's happening within the application or system. So it really allows for deep analysis and debugging. And we'll see some pictures here. So monitoring here, when issues are occurring. Observability, where and how in the system are these issues occurring? So if I collect data in multiple places throughout the system, then I can start to understand, well, the issue seems to occur between the second step and the fourth step of my application. So I know even more information about what's happening in my system. And then with observability comes tools like tracing, so something that's very popular to capture information about a single execution of a software program, often for debugging purposes. And we do tracing for our guardrails and our LLM secure application. Okay, so let's talk about challenges for generative AI text and LLMs. So for kind of our standardized simple evaluation metrics, the first things that you learn when you do machine learning, they're really focused on simple outputs to our models. So certainly non-generative outputs. So for example, classification. This is a model that produces some class. You have a fixed list of classes and you're trying to select one. In the example on the left here, we see the iris dataset, a very classic dataset in machine learning. So we have 3 different classes here. And this allows us to create this confusion matrix, and from that create a bunch of metrics that we're used to. So accuracy, F1 score, precision, recall, so on. Regression has numerical outputs. So we have a different set of metrics that we can calculate, but it's fairly easy to calculate them when we have them. And we have things like clustering that I mentioned. But once we move over to text, even using labeled evaluation is very tricky. And it only gets trickier after that. So for example, let's say that we have a system that is going to produce a sentence. And our prediction here is on the top. The sentence it produces is, this sentence is an example, or is just an example. And let's say we have some reference. So that reference, someone, we sent to some humans, or we've collected somehow what we believe to be like a golden example of how our system should have responded. And the reference response we have is, this writing is used as demonstration. These sentences are quite similar. And we'd love to see a score that's quite high, but just doing that comparison alone is very, very difficult. And there's a number of different metrics to allow us to do this for text, all with many flaws, but things like blue score or rouge or BERT score that really look at these different words. Maybe in the case of BERT, uses contextual embeddings to try to find the meaning of this word. But for Blue and Rouge, really look at individual words and pairs of words and try to, make sure that even if the organization or the structure of the sentence is different, that we're having some overlap and that we can measure that overlap. But there are many more text-specific concerns that we might have. So this is an example of a text that your LLM might respond with for a question maybe about a Nobel Prize in physics in a certain year. So in this sentence, there is a lot of named entities. So the date, the organization, several people's names, and the Nobel Prize in physics itself. So we want to know some information about this. Not only do we want to know the number of sentences or the similarity of this sentence to another, it's helpful to understand, well, how many specific terms are we using in our sentence? This sort of thing. And for LLMs, there's even more complex things to think about because of the structure. So we have prompts, and then they come out as responses. There's a conversation, so there's some history and things to measure, right? The response of an LLM in the middle of the chat may be much more concise, but still accurate, right? Because I can use pronouns or propositions to refer to things that I've said earlier, right? I might say, not like what I said above, or something like this, as opposed to giving a full response. Okay? And LLMs present their own metrics and concerns that we have to think about. So this is an example of a hallucination. You may have seen hallucinations before. I won't go too in depth about this, but the case where the LLM produces a response that seems pretty accurate, but actually isn't for a number of reasons. And very difficult to detect because just looking at the response, you may think that this is an appropriate response. Okay, so we think a lot about this and have included a lot of this inside of LangKit, which is our open source tool. And so this is all about the text and LLM specific metrics that we have to think about for LLMs and text. So we need to translate those prompts and responses to useful forms, and we need to inform critical business and operations questions. There's a number of metrics that we produce in LangKit. So for example, text quality, so like readability score, grade scores, similarity between the prompt and response, or similarity to themes, patterns in our data, refusals, that sort of thing, sentiment. Okay, so let's move on to comparing evaluation techniques for accuracy, realism, and convenience. So we built up all of these definitions. We've kind of looked at text and how this changes things, how LLMs change things. Now let's actually think about the evaluation techniques and data sets that we need for this. So a couple more concepts, and then we'll get to this. So intrinsic evaluation. This is about assessing based on specific tasks or benchmarks directly related to the model itself. Extrinsic evaluation is really about evaluating the whole of the application. So this maybe is more helpful in understanding what's happening here. Intrinsic evaluation is really LLM specific and sometimes even specific properties of the LLM. So for example, I may want to test whether or not my LLM gives truthful answers or gives like very factual based answers, or gives a very high sentiment or something like this. That's very different from or just answers some random question correctly. That's very different from my extrinsic evaluation, where I care a lot more about what is the particular application that I'm using this LLM for, and how well does it work on that task. Often what we see is that intrinsic evaluation, there are many academic data sets that evaluate specific properties of LLMs or specific questions, but they can feel a little arbitrary or kind of like toy examples, or just not directly related to your application. But we can get some nice labeled data to be able to evaluate this and some detailed data. Extrinsic evaluation pretty much has to be collected by you for your application, right? Because you're using this in a specific way, and we want to measure this on our overall application. And so this most often takes real data from some real application, and it doesn't always have labels. And when it does, it normally was a painful process to get that, except for a couple of exceptions. Okay. Now, offline evaluation is where something we're probably most likely to see, where we use some historical data that we've collected before the evaluation. So some data set we downloaded, something like this, and to evaluate our model. That is in contrast to online evaluation, where we want to run this in production and test the real production environment for our task. Okay, so offline evaluation, just in picture form, we see here on the left with our static training data set, while online evaluation is with live production data. Okay, so now let's start thinking about specific data sets for different types of evaluation. So we have online intrinsic evaluation with labeled publicly available data sets. So these are the sorts of evaluations that you're likely to see in academic research, although they are widely used in industry to test our systems as well. Why is that the case? Well, these are moderately sized data sets, sometimes small to maybe medium sized data sets, but they have full labeled data that someone likely paid for, some grad student or undergraduate students or crowd workers to label this data. Some examples of pretty large data sets that are very popular are Stanford's Helm set of data sets. So these are a set of many different data sets for many different tasks. But those tasks, again, are these sort of academic tasks that you're used to seeing. Same for MMLU. So, and glue and super glue as well. So these tasks are things like, let's see, many examples, but so things like translation, things like natural language inference. So maybe if I give you two sentences and I say, hey, does this first sentence entail the second sentence? That sort of thing. Let's stick with that one. That is not something that your users are likely using your LLM for. I'm asking, this kind of formal question about entailment, but understanding how well our model works on that task can tell us, about issues in our model. And it's just something that we've kind of adapted because of the academic data sets available to us. Truthful QA is an example of data sets that is combined with some real facts to see how well an LLM reports accurately on facts. This is very different from unlabeled data sets, which already are starting to get more realistic, but you can have things like malicious prompts lists where people maintain lists of different types of prompts, or lists of sorts of questions. There's a website that has kind of FAQs for insurance. So these are all the questions that they've kind of received for insurance. In some cases, they might come labeled. So if they have answers, then maybe those can be used as the labels. But often you might find a list of questions that come unlabeled. And sometimes there's a little bit of a mix here. So unlabeled data that is very specific may end up being kind of a data set that's all labeled positive. So for example, a malicious prompts list, this is if the question that you're asking is whether or not this prompt is malicious. Well, if I captured a list that claims that all of them are, that's technically a label. Okay, now let's move to the other extreme, since we're right here at time. And that other extreme is online extrinsic evaluation. First, we'll start with labeled data. So for example, we might collect traffic from our website and manually label for ground truth later. So no matter what the problem is, because this is extrinsic evaluation, this is particular to your application. And if we want labeled data to be able to capture things like accuracy and some of the standard performance metrics, we need to go and manually label that. Some examples where you don't have to manually label are things like demand forecasting, where maybe with time, you'll naturally get the answer. So if I'm a company that does deliveries, let's say, and I want to predict how long it takes to do a delivery, well, it turns out at the end of the day, I will know exactly how long the deliveries actually took, so I can use those to compare to what our model produced. Okay, and then finally, unlabeled data for online extrinsic evaluation. So this is about collecting traffic from your website, but you don't have the ground truth. And this relies very much on that kind of list of metrics that we saw for LangKit, where we want to capture questions like, what are the chances of hallucination? What is the variance in the toxicity of the language? That sort of thing. This is so valuable for production settings, and something that we've spent a lot of time working on and perfecting at Y Labs, and we continue to add more evaluation to make things really usable and really helpful for both production environments, but also academic environments as well. But in production settings, we're really much more likely to have this sort of online production system where we want to understand how well this model not just works in general on hypothetical questions or toy questions, but how well it works on our task. And we don't have labeled data available to us. Okay. And with that, we are at time. I'm happy to take any questions and happy to follow up on any conversation via email, social media, or join our Slack group at Y Labs, and happy to continue the conversation there. Thank you.